Hi, my name's David Townsend and I'm a partner sales engineer here at Juniper Networks, and it is my pleasure to show you and to take you through a presentation to present to you Juniper's automated data center solution, which is Apstra. So over the next 30 minutes or so, I'll be talking about Apstra, what it is, the benefits behind it, and briefly how it works. And the second session, the second, third, and fourth session, we're going to go into the user interface, the UI of the Apstra solution itself, and then you're going to see from a UI perspective the real power, agility, and speed of this Apstra data center solution. So if you have any questions following this session, please email the experts, the sales team at kubus.com, so sales@kubus.com, and of course they will be happy to answer any questions that you may have. So Juniper has a complete client-to-cloud enterprise solution, and this encompasses all the elements that you see here to really deliver the best IT and user experiences. And the Juniper experience first, the experience first solution, it has the following network components. First, the AI driven enterprise, and this includes wired and wireless access and session smart SD-WAN, all driven by Mist AI. We also have the automated WAN solutions for linking different offices and data center facilities with reliable connectivity, which is tunnel-less technology using a new standard called SVR, Secure Vector Routing. And for this session, for this topic, is our cloud-ready data center for scalable connectivity and simplified underlay and overlay management with assurance. And of course, throughout this is our connected security strategy, which is a common bond that ties together all of the above by extending visibility, threat intelligence, and enforcement across our entire portfolio. Now, intent-based networking is a bit of a buzzword in the industry these days. But there's a lot of meat behind the idea, and the whole idea of intent is to describe what the network should do, describe the what. And architects have been doing this for an incredibly long time. When they design the network and the service that the network is going to be providing, for example, layer 2 connectivity between some set of servers, routing policy to transition between a couple of subnets, some sort of security policy that might define how traffic is permitted to travel. That's all part of the what. So when we talk about intent, we're talking about using an automated and disciplined approach to design the network in a repeatable fashion. And this way, we have some building blocks that are simple to grasp and understand and are easy to deploy consistently. And then the intent-based system or the software, it then delivers the how. So with Apstra, the what is designed in more generic terms using blueprints. In other words, the framework that we use to describe the what is not vendor specific. They're not Junos, Cisco, or anybody else's configurations. They are understandable terms that describe the intent or the what. The software converts that into configurations and pushes them under or into the system, if you want to think of it. And because of this, Apstra is multi-vendor capable. It works great with Juniper, of course, but it can also be used in other single or multi-vendor environments. And since Apstra is an intent-based system, it understands what was required in the very beginning and how the network was intended to be deployed. The Apstra system is deployed in the network. It deploys the network, so it understands what it is supposed to be doing, and it continually collects analytics from the system and feeds back to the operator what's happening in my environment. And it compares the operational state, i.e. what's happening on the network, with the intent, and it provides feedback, troubleshooting tips, and root cause isolation very, very quickly. And the design tool, the automation, That's all very important, but the real value here is that day 2 plus operational benefit, and that's where we see the biggest benefit and cost savings. So as I said, Apstra is a multi-vendor solution. So we take the intent, and it doesn't matter about the vendor. We put that into the software writes into the relevant COI for each of these different vendors, which is how we're able to have a multi-vendor solution. And using this design, build, deploy, and assure framework, we're then able to offer a closed loop assurance, because we've designed and built the network itself based on our intent, how many servers you want, the speeds, the links, what's connected to who, the security policies, the routing policies. You know how the network is designed and built, and you've deployed that onto your network using ZTP, of course. Because you know this, we're able to then, using telemetry, to provide assurance on the network and make sure that the performance of the network and how it's actually operating has not deviated away from the actual configuration, i.e. that of the actual intent itself. So yes, this is a vendor agnostic solution. It supports clause 3 clause or clause 3, however you want to put it, super spine or pods, as well as a collapsed core. In terms of the building, is the single source of truth, because you know the intent, and if there's any deviation, you can always reference back to what's called the graph database to make sure that you check this single source of truth, has it deviated. You can also, because you've built the design on Apstra, you can download the cabling map, or even if the data center is deployed before Apstra is connected, you can upload the cable connection into Apstra. There's time voyager rollback, so human error is still the number one fault on any network. If a fault occurs in terms of configuration on the network, you can roll back in time as such the configuration of the entire network to a more stable condition and condition and environment, and ensure we're providing day 2 plus operations, identifying root causes, providing continuous evaluation, and much more. So Juniper's data center fabric architecture, EVPN VXN over IP fabrics with Junos as the single OS with its telemetry capabilities. Yes, absolutely, all that is very important. And wrapping the Apstra Fabric Conductor platform on top of that data center architecture gives us an extremely powerful operations tool and management tool. And this intent-based assurance approach is a really exciting way to operate networks. It solves a lot of the shortcomings we may have had in the past with fabric management. So it's a really compelling and extremely competitive fabric management solution. And it is wrapped with APIs and all the tools that would be needed if you wanted to venture down the path of infrastructure as a code. And those APIs, they can be used as part of a DevOps workflow. So it is open, it is multi-vendor, as I've already mentioned. And here's just taking a little bit more concept into how we adopt a multi-vendor approach. Well, we're basically providing an abstraction, note the word abstraction, hence the name Apstra. We're abstracting the physical hardware elements away from the logical devices, away from your intent. The logical devices, that could be a leaf, could be spine, could be lean spine, doesn't matter. You are defining what that logical device looks like in terms of port count, where the connections are from, leaf to spine, spine to leaf, spine to super spine, etc. How many ports you need, what's connected to these ports, is it an access switch, is it a generic system where it would be a firewall or a server? That's your intent, that is the logical device, that's your logical connections. And then via what's called an interface map, we're then able to map that logical device to any one of those vendors and all the different models and types etc., via device profiles. So in terms of day zero fabric design, we first have to build the racks themselves. So the racks where you have a top of rack leaf predominantly. It might be one leaf, it might be two, it might be more, depends. Every architecture, every deployment is different, is unique in my experience and humble opinion. But in the rack design, you're defining the racks themselves. And in this particular illustration here, we've got bare metal servers, we've got dual servers, which are multi-homed to different leaves. You're really defining here what the connection is and who's connected to what within the racks themselves. And via the logical devices, once you've defined the logical devices, you can say, yep, this leaf is and via their interface app is Cisco, it's Juniper, it's Arista, so on and so forth. But once you've defined your racks, we're then going to apply this into a template itself. And the template is where you define that spine layer or the super spine layer as well, if we talk about pod-based architecture. And here, this is your fabric design. You're defining, furthermore, how everything is interleaved, how everything is connected, where the external gateway is, so on and so forth. And you also, within your day zero operations, you define your resources. Now, this might be a resource, a pool of IP subnets, of ASNs, of VNIs. It's really defining the resources you need to eventually deploy this blueprint, which is what this is all building towards, this blueprint onto your network itself. And as I just mentioned, the fabric blueprint. So once you've defined your rack and the rack's going to a template which create your fabric design, all of this creates a single source of truth, because this is all based on your intent, i.e. what you want to be configuring and deploying and assuring on your network itself. This is your single source of truth. In terms of day one fabric deployment, we of course can provide full control over the different elements that you're connecting to Apstra, regardless of the vendors that you've seen mentioned already, or you can receive telemetry only. And we have this concept of agents, i.e. on-box, off-box agents. So just for example, for Juniper, for our QFX series, we provide off-box agents, which basically provide a netconf over SSH, obviously securely to the different devices, and the same concept with on-box agents to bring these devices under control and management of the Apstra solution using ZTP. All the configuration is pushed down from the Apstra solution onto the devices themselves. And of course, you can define spine 1, spine 2, so on and so forth. Yeah, this is Juniper, this is Arista, Sonic, Cisco. It's really just saying here, based on system IDs, who is what in terms of who's who on the network. And again, once you've configured this and you've deployed your network, because you've created the blueprint, again is with reference back to a single source of truth. So this is constantly building up, and there's a relationship between all these different nodes, as they're called in this graph database, the single source of truth. In terms of day two operations, there is a lot that Apstra can do, and of course for a data center environment, an operator needs of a lot of capabilities in terms of day two operations plus, and Apstra absolutely delivers on this. So whether you have a single or dual home server, Apstra solution is able to build, manage, deploy and assure those types of connectivities. We're also able to expand on the links, leaves, the racks themselves. We can roll back. I mentioned this a few minutes ago using the time voyager. So if a wrong configuration is pushed down from Apstra onto a particular device or devices, and or whatever it may be, you can roll back that changed to remove that configuration, whatever that may be. You can also enter into device maintenance mode, which allows you to essentially drain traffic off of the actual leaves, spines. So you're draining traffic in order to provide some kind of upgrade, or maybe it's a hardware swap out, whatever it might be. Obviously, this will take time because what we're using here is essentially ACLs, which will be pushed down automatically from Apstra onto whatever solution it is, wherever it might be in the data center, to actually slowly drain traffic off that in a secure but stable way, meaning that adjacency, so on and so forth, won't drop out. It will all be done securely and in a stable manner. We can also provide a topology view, of course, of the of your network itself, and using a heat map, seeing where most of those events or anomalies are actually occurring on your network. So there might be an anomaly within BGP, within cabling, within some kind of adjacency. The list absolutely goes on, but you're able to see within a heat map what device for what specific area is experiencing most heat, i.e. the biggest amount of anomalies themselves. I'm not going to go through all of these, of course, because I'm becoming conscious of time, but yeah, a layer 2.3 service view dashboard, which you can program, I should say, customize yourself, and also anomaly detection, the ability to detect any anomalies via intent-based probes. So you can use predefined intent-based probes, or you can create your own with customed events in different stages to monitor, for example, in a MC lag environment, or let's use a lag peer. Is there adequate load balancing between the different within the link aggregation group? Is there relevant load balance sharing in a ECMP environment between the different spines that the leaves will be connected to? So these are, there's a huge list of different anomalies you can use, and the intent-based analytics as well really complements that. So to summarize, well, actually, no, I'm going to go a little bit deeper into what we mean by this data operations, because the last few slides was quite high level and more bullet points. But I want to go into a bit more information into what data operations are and what we can do. So as you know, we have this intent, we have the intent, and we have an understanding of what the network is supposed to do. And because Apstra deployed the service, it's then able to have a really solid understanding that's supported in its graph database technology. But then it will actually collect network events from agents that run on the switches, from telemetry feeds that we can collect from those switches, and from things like syslog and any sort of representation of activity on a switch, on the switching fabric. And all of this is fed into this intent-based analytics system, which compares that data or those network events against that single source of truth, or really that intent. And then this can extract, Apstra can then extract knowledge from that. Now, you've probably clicked onto this. One of the problems with huge amounts of analytics is if you don't know what to do with that analytics, it's just noise. And the Apstra solution, the Apstra system is able to compare those analytics, all the analytics, against that single source of truth, against the intent. And because it has the single source of truth, because it knows your intent, is able to extract the usable knowledge from all of that data, from all of that noise, to be able to provide feedback to you, to the operator. So if there is an unintended operational state, like if somebody logs into a COI and manually made a change, or if one of the links in the network is running a little hot, a little bit overwhelmed, and we're not getting proper load balancing, or if there's a failure somewhere in the network, that is identified very quickly as an unintended operational state. And where that condition is happening is compared against that intention. It's quickly reported back to the operator so they can visually see and isolate and troubleshoot that problem instantly. And when things are operating well, now we have a dashboard. So in essence, in summary, as I started the slides showing, in summary, Apstra, it knows your intent, it's using the single source of truth. And even though we're getting huge amounts of analytics and telemetry from the network that's connected to Apstra, we're able to filter out all of that white noise and to really concentrate and report, manage and isolate and troubleshoot back to the operator very quickly what they need to know, what they need to see. And all of this together is really eliminating the outages, it's lowering that mean time to instance, and it's able to provide, as I said, that closed loop validation. Because of that intent, because you've built, deployed, designed, and deployed your intent and the insurance, we're providing that closed loop validation. So what else can you do in day 2 operations? Well, of course, we can provide connectivity templates. So within connectivity templates, you could say, yeah, connected to this leaf is a server, it's a hypervisor, or whatever it may be, and you're able to define static routes or tagged, double tags, untagged connections to it. There's different templates for this, and of course, you could define peering, such as BGP, to these servers, whatever it may be. You're basically providing the connectivity via template in a repeatable fashion to reduce human errors and to speed up deployment time and all the benefits associated to that between the leaves and the attached network devices themselves. So whether it be a firewall, a generic firewall, or from Juniper, we have our SRXs or an MX core. Maybe that's providing some kind of border routing or external gateway as such, or servers themselves, you'd use connectivity templates in a repeatable fashion to provide that connectivity. And of course, there are routing policies as well as security policies as well to define essentially who can talk to who, what do you want to filter out, i.e. who do you not want to talk to who. And of course, all the details therein, subnets, EVPN, VXLAN, routing policies, but because we're using these policies, we're able to really drive forward the efficiency of Apstra to deploy these policies, and via the day 2 operations to ensure that, again, that those policies, that what's happening on the network is not deviating away from the intent itself. And just for example here, we also have configurates, and the list goes on, but configurates are a way for an operator to push a script, I like to think of it, or a mini command line interface, really. Doesn't matter about vendor. A typical switch will have hundreds, if not thousands, depending on the capabilities of the switch, will have a lot of COI commands. And I'm sure any vendor will say you don't want to see all those capabilities on a dashboard, on a user interface, on a software solution itself, because the UI would be overwhelmed. It'd be messy. It would be very compact with different buttons you can check. But the configurates basically allow you to push down a configuration change which is not supported by the Apstra solution for a particular vendor. Now, there might be something like DNS, might be something like Radius, TACACS, SNMP, NTP, etc., etc. So this actually allows you to improve not only the configuration of the network via Apstra, but also to change the configuration and the intent of your network via day 2 operations using the Apstra solution as well. So moving to closing off now, it's very important to, of course, mention, it's important to be partnered, is what I wanted to say, with a leader in technology, and we are actually very proud that we have been recognized across the board by Gartner for our technology innovation, our ability to execute, and strong market momentum. And as you look across all these areas, whether it be wired, wireless, for data center networking, for WAN, edge or SD-WAN, we do have noticeable recognition in all of these different areas. And of course, for this particular session here, for this topic, we are a leader in the 2021 Magic Quadrant for data center and cloud networking. And also there was a recent public report that came out from Forrester called the Total Economic Impact of Juniper Apstra. I'm not going to read all of this, but it really defines the impact, the significant impact that Apstra has in a data center environment, how much it can speed up operations, how efficiently it can do so, and of course the savings in terms of day 0, day 1, day 2 plus operational cost savings. And as you can see here, the typical payback and return on investment. So it is a very good read, and I would invite you all to look at that report, of course. Oh, to finally finish off, and as I said at the beginning, if you have any questions, please email those to the team, sales@kubus.com, and they will be happy to come back to you. Now, thanks for your time. Thanks for listening. I hope you found that insightful and useful, and I look forward to session 2, where I'll be taking you through how to build your intent on the Apstra solution. Thanks very much, and goodbye.